Now let's just move on further towards a new concept which is all about the areas of the sector and the segment of a circle. So let us suppose if I'm just starting with the sector. So what is the meaning of a sector? So we all know the portion of a circular region which is enclosed by the two radii and the corresponding arc is actually called as the sector of a circle, and the sector of the circle are of two types. Means, let us suppose if I'm just talking about this particular circle, and we can see that these are nothing but the two radii of the circle, and this is nothing but the arc. So if I'm just talking about the area which is enclosed by these two radii and these arc, this is nothing but called as the sector. So a sector is of two type, which is nothing but called as a minor sector because it is a minor portion. This is called as the major sector because it is a major portion. So hence the sectors are of two type, a minor sector, a major sector. So as you can see over here, the sector is actually formed by enclosing an area within the two radii and the corresponding arc. This is the corresponding arc APB for the minor sector, and this is the corresponding arc AQB for the major sector. So this is all about the sector. So remember always that if we are talking about the sectors, then there are two types of sector: minor sector, which is enclosing the minor area; major sector, which is enclosing the major area. Now in the same way, if I'm just moving on further towards the segment, what is the meaning of segment? The portion of the circular region which is between a chord and the corresponding arc is called as the segment of a circle. So let us suppose if I'm just taking this particular figure. So this is my chord. As you can see, AB is nothing but a chord which is intersecting this particular circle at only these 2 points. So this is nothing but called as a line segment which is intersecting this circle at point A and B, and thus it is called as a chord. So this is a chord which is forming two segments over here with respect to the two arcs. First is APB and the other is AQB. So with the smaller arc, it is making a segment which is called as the minor segment, and this is nothing but called as the major segment. So for the minor segment, you can see the arc is nothing but APB, and for the major segment, the arc is nothing but AQB. So hence again, in the similar way like we did for or we talked about the sector, we can talk about the segment as well, that the segments are nothing but the portions of the circular region which are made between a chord and the corresponding arc, and they are of two type: minor segment and major segment. Now let's just move on further because we just wanted to talk about the areas of the sector and the segment of a circle. So let us suppose if I am just moving on further with the sector. So first of all, if I'm just taking the angle which is made by the two radii and the corresponding arc at the center of the circle as theta. Let us suppose if I'm just taking this as my minor sector, and I am just taking this angle as nothing but theta, which is actually formed by the two radii and the corresponding arc at the center of the circle, which is nothing but theta. So since we know that the area of this particular circle is nothing but is equal to pi r square, we already know about this concept that the area of the circle is pi r square, where r being the radius of the circle. You can see over here that r is nothing but the radius of the circle. So using the unitary method, or by the unitary method, we can say that when degree measure of the angle at the center is nothing but 360 degree, when the degree measure of the angle at the center is nothing but 360 degree, then the area of the sector would be of the type pi r square. We definitely know about this concept. When we are taking the angle as nothing but 360 degree, then the area of the sector should be nothing but pi r square. But if we are just taking the angle as nothing but theta, if we are just taking the angle as theta, when the degree measure of the angle at the center is theta, then this should be nothing but pi r square divided by 360 degree into of theta. Obvious concept it is. By unitary method, we can say about this fact that when the degree measure of the angle at the center was 360 degree, then the area of the sector was pi r square. But if the angle is nothing but theta, then it would be nothing but pi r square divided by the whole angle, that is 360 degree, into the theta angle that we have taken over here. So hence at the end, what we have concluded? We have concluded that the area of the sector, which one? This one sector, which is nothing but the minor sector, is nothing but theta by 360, or you can say that pi r square by 360 into theta. Most of the time we consider it as theta by 360 into pi r square. So let's just move on further. So hence we actually have concluded that the area of the sector of the angle theta is nothing but theta by 360 degree into pi r square, This is nothing but the area of the sector. Which one sector? Minor sector. So we have concluded that the area of the minor sector that we are getting is theta by 360 into pi r square. Now let's just move on further toward the area of the segment, that how we can calculate the area of the segment. Now again, let us suppose if I'm just taking the same figure over here. So we know that this shaded portion is actually the segment. This shaded portion is the segment, and we just wanted to find out the area of this shaded portion. So this is quite an obvious task to find out the area of the shaded portion, because we know that we already are aware about the area of this whole sector, that is OAPB. The area of this whole sector OAPB is nothing but theta by 360 into pi r square, and we just wanted to find out the area of the shaded portion. So if I'll subtract the area of the sector with respect to this area of the triangle, as you can see, AOB is the triangle which is not required at all. So if I'll subtract the area of this particular triangle from this area, then I will able to find out the area of the segment. So it means that by applying the unitary method and taking the whole length of the circle as 2 pi r, taking the whole length of the circle as nothing but the 2 pi r, we can say that the length of the arc APB. Before the segment, we are just talking about the length of the arc APB of the sector of angle theta. It should be nothing but theta by 360 into 2 pi r. So before finding out the area of the segment, I'm just talking about finding out the length of the arc APB over here, because it is quite important to find the length of an arc before the area of the segment. So here you can see we can able to find out the length of an arc APB of the sector as nothing but theta by 360 into 2 pi r. So this is again the formula through which you can able to find out the length of the arc APB of the sector of the angle theta. So this is the formula with the help of which you can find out the area of the sector, the minor sector, and using this formula you can able to find out the length of an arc APB of the sector having the angle as nothing but theta, which is theta by 360 into 2 pi r. So these are the two formulas. Now let's just move on further and talking about the segment. So as you can see over here, the area of the segment APB, the area of the segment APB, like we discussed before, is actually nothing but is equal to the area of the sector OAPB minus area of the triangle OAB. You can see all by yourself, like we discussed before, that area of the segment APB can be calculated by subtracting the two areas together in such a manner. So if I'll plug in all the values over here, then I will get the formula for the area of the segment APB as nothing but theta by 360 into pi r square minus area of the triangle OAB. And we already know how we can find out the area of the triangle. Either we can use half into base into height, or either we can use the Heron's formula to find out the area of the triangle OAB. Now similarly, in the similar manner, we can proceed further for the area of the other major sector or the major segment. So we can say that the area of the major segment or the major sector OAQB should be nothing but area of the whole circle minus area of the minor sector. We already know that the area of the minor sector is nothing but theta by 360 into pi r square, and further in order to calculate the area of the major segment AQB is actually nothing but the area of the major segment. So this would be nothing but pi r square means the whole area of the circle minus the area of the minor segment APB. So using this particular concept, we can able to find out the area of the major sector and area of the major segment. So hence at the end, what we have concluded the important formulas through which we can find out the area of the sector and the segment of the circle, and the length of the sector as well. So in the very first concept, we have concluded that the area of the minor sector is actually nothing but theta by 360 into pi r square, and then we know that in order to find out the area of the segment, we can use a concept of subtracting the area of the minor sector with respect to a circle, means the area of the minor sector minus the area of the triangle OAB. Using this formula, we can find out the area of the major segment and the area of the major sector. So this is all about the concepts or the formulas that are related with the area of the sector and the segment of a circle. Now let's just use all these formulas in order to find out the problems that are related with it.